Hello everyone. In this lecture we want to talk about applications of higher order derivatives. Okay, so it says the position of a moving particle which moves on a straight line is given by the equation S of t equals 2t cubed minus 21t squared plus 60t, and of course t is greater than or equal to 0 because t is time and time cannot be negative. And time is measured in seconds, S is measured in meters in terms of units of measurement. It's an application question after all, it's a word problem. And it says find the velocity after 3 seconds and 6 seconds, okay? So what we're going to do, we're going to say when you have a position function or the displacement function in physics, we know that the rate of change of displacement with respect to time is defined as velocity in physics. And rate of change in calculus, we said that it is nothing but the derivative of the function. So we can say v of t, or the velocity, is actually ds over dt in Leibniz notation, or we can say this is s prime of t, basically. Okay, so the derivative of the position function is going to be s prime of t, or ds over dt. We take the derivative with respect to time, and that becomes the velocity function. And again, in physics, there's another definition for acceleration, which is the rate of change of velocity with respect to time. So if you differentiate velocity with respect to time, you are going to generate a new function called the acceleration. So that would be dv over dt, basically. Or you can say, because v itself was the derivative of the position function, so you can say acceleration is actually the second derivative of the position function. So d2s over dt squared, you can say, or you can say s double prime of t or v prime of t if you want to use the prime notation. So these are the definitions which can be defined: position function, velocity function, acceleration function. And here they're looking for the velocity, of course. So what I should do, given the position function, first of all, I have to find the velocity function. And how do you do that? By taking the derivative of the function, which is s prime of t. And that gives you 6t squared minus 42t plus 60, right? So that is the derivative of the position function. In other words, the velocity function. Now, if you want to find velocity after 3 seconds, simply you plug in 3, right? So if you plug in 3 here, it's going to be 6 times 3 squared minus 42 times 3 plus 60. And if you do the math, you get negative 12 meters per second, okay? And if you plug in, for example, 6, you end up with positive 24 meters per second. So these are the answers. And we see that one answer is positive, one answer is negative. And that obviously means that the object was, or the moving particle was moving in opposite directions at time t equals 3 compared to t equals 6. So we don't know what's happening. We need to figure out later. So one thing for sure I know is that at t equals 0, s was 0, because I noticed that s at 0 equals 0. So if I draw a number line like this, okay, if this is like s, okay, which is the position of this moving particle, I would say if this is the origin and that is 0, we will see what we are going to end up with. 1 second, not 1 second, maybe I should go up by, I don't know, maybe 20 meters, 30 meters, or no, if it's 20, then it should go up like 40 and 60, right? So I still don't know, so I just put some numbers there, 80 and 100, and here negative 20, negative 40, negative 60. But all I know is that this moving particle was at the origin. You know, at t equals 0, I can say at t equals 0, s at 0 was 0. So that much I can say. But then after 3 seconds or 6 seconds, maybe it was moving to the right, to the left. We don't know yet. We have to figure things out. It says, when is the particle at rest? The meaning of at rest is V is 0. And if the moving particle is not moving, is at rest, it means that the velocity is 0. So that means that I should set 6t squared minus 42t plus 60 equal to 0. That's the equation. If I factor 6 out, we get t squared minus 7t plus 10 equals 0. And perhaps we can factor the quadratic trinomial here. Two numbers add up to -7 with the product of 10 would be -2 and -5. So that's the next part. And from here, I can conclude that t minus 2 is 0 or t minus 5 equals 0. Okay, so that means, therefore, t equals 2 and t equals 5 seconds. Okay, so we know that at t equals 2 seconds and at t equals 5 seconds, the particle was at rest. Okay, that much we know. So perhaps it was moving, to the right for like a couple of seconds, and then it stops, changes its direction, and then moves in the opposite direction. And again, at t equals 5 seconds, the speed is 0, which means that, again, the particle did stop, and then perhaps it was changing direction. So something like this maybe was happening here, and then makes a U-turn, and then makes another U-turn like that. So here is at t equals 2 seconds. Here is t equals 5 seconds, because here is when velocity is 0, and here velocity is 0. And this was the original point where t was 0 and s was 0. Okay. But velocity, is it 0 or not at the origin? Let's plug in here 0. V at 0 is 60. So no, it was moving actually. It was moving at time t equals 0. It didn't have initial velocity. It was moving with a speed of 60 actually in the positive direction apparently. It was moving from left to right, and then it stopped after 2 seconds. Velocity becomes 0. It makes a U-turn, goes back in the opposite direction. At t equals 5 seconds, we just found out. Okay, it stops again. Why? Because it wanted to change its direction, and then moves in the other direction forever because it never stops again. And because we only had 2 routes for the v of t equals 0. Now it says, when is the particle moving in the positive direction? Well, positive means v of t has to be greater than 0. That's the meaning of it. And this means that 6t squared minus 42t plus 60 has to be greater than 0. And that means that I have to solve this quadratic inequality. Welcome to advanced functions, right? Okay, so in order to do this, we already have the factored form. That was 6 times t minus 2, t minus 5, greater than 0. I need to construct a chart actually to determine the sign of this quadratic trinomial. So in the top, I have my variable, which is time. It's t, and it starts from 0, obviously. So we start with 0. Theoretically speaking, it goes to positive infinity. And we had 2 points, 2 and 5, where velocity was 0. 6 times t minus 2 was one factor. T minus 5 was the other factor. And v of t, velocity, is what we are interested in. We're interested in the sign of v of t. So we're going to construct a chart, and we're going to subdivide it into intervals. And I'm going to say t minus, if t is equal to 2, t minus 2 is 0 for sure. So to the right would be positive, because if t is greater than 2, then 6 times t minus 2 would have a positive value, obviously. But if t is less than 2, then 6 times t minus 2 would have a negative value. Okay, imagine if t is like 1.5. So if you plug in 1.5, you end up with a negative value, right? And t minus 5 is 0 here, to the right positive, to the left negative. The product of them is what makes the velocity function. So we have positive, negative, positive, 0 and 0. Now, we know over what interval v of t is positive and over what interval it is negative, apparently. So we're going to say v of t is positive if t is between 0 and 2 or when t is greater than 5. So if within these intervals, we just discovered from our table, excluding the middle part, we should not take this part into account because that's where velocity is negative. So within this interval, it's moving in the positive direction. So from 0 to 2 seconds, that's moving to the right. And then 2 to 5, it's moving to the left in the negative direction. And then from 5 towards infinity, it is again moving in the positive direction, and that is to the right. How did we figure this out? It was because of the chart. We could find out the intervals over which this quadratic trinomial was actually positive. And where this equation come from to begin with, it came from the derivative of the position function, of course, okay? Now, right now here, I just came to my mind, I can add another part. So part E, I would say find the acceleration of the particle at t equals 3 seconds. So acceleration, we just said, a of t would be the second derivative of the position function or the first derivative of the velocity function. And if you differentiate, it's going to be 12t minus 42. So 12t minus 42 is the equation of the acceleration, which is a function of time. And after 3 seconds, so a at 3 would be 12 times 3 minus 42. That's 36 minus 42. So negative 6 meters per second squared. That is the acceleration after 3 seconds. Just came to my mind. I said we can add this part to the question. We found the velocity function. Why not, finding the acceleration function as well? Okay, because the acceleration is the first derivative of the velocity function or the second derivative of the position function. Now here it says find the total distance traveled by the particle during the first 6 seconds. So the first 2 seconds it goes to the right, and then another 3 seconds moves to the left, and then another 1 second moves forward, so that we reach, let's say here is like t equals 6 seconds. So we need to find all these distances, and we have to add them up. It says total distance. So I need to find a distance from t equals 0 seconds up to t equals 2 seconds because it was moving to the right. And then another distance I have to find from t equals 2 seconds to t equals 5 seconds. And then I have to find another distance from 5 seconds to 6 seconds. Okay, that's the story here. Now, this equation, it only gives you the position of the moving particle. Okay, it doesn't give you distance or anything like that. So I would say the first distance I need to calculate is from 0 seconds to 2 seconds. You would agree with me. So in order to find this, I said s at 2 minus s at 0. So whatever position it had at 2 seconds minus whatever position it had at 0 seconds, which we know it was 0, it was starting at the origin, that difference would be the distance traveled, right? But the thing is that when you plug in these numbers in the equation, you may end up with negative answers, positive answers sometimes. So that's why we're going to take the absolute value of this so that everything would be positive. So I'm going to plug in like 2. It's going to be 2 times 2 cubed minus 21 times 2 squared plus 60 times 2. Then minus s at 0, which is 0. And then I'm going to take the absolute value of this, because just in case if the answer is negative, we don't want to say distance is negative, of course. So we end up with like 52 minus 0, which is 52 meters. Okay, so that is the distance traveled from 0 to 2 seconds. So I would say here is like 52 meters, apparently. And then from t equals 2 to t equals 5, I would say s at 5, position at 5, whatever it was, minus the position at 2, taking the absolute value again, that would be the second distance, or d sub 2. If you do the substitution, you get 25 minus 52, subbing 5, subbing 2, okay, in the equation. And this gives you a negative answer, actually. It gives you negative 27, all right? But we don't believe that distance is negative. So the distance traveled is positive. We have to take the absolute value. So it is true that it was moving in the opposite direction to the left, but it doesn't mean that the distance traveled was negative. So that becomes 27 meters. So that's from here to here. And then from 5 to 6, that's the third distance. So it will be s at 6 minus s at 5. We take the absolute value again. So that will be like 36 minus 25, which is, of course, a positive answer. So that's 11. Absolute value of 11 is just 11 meters. So these are the positive distances traveled over those time periods from 0 to 2 seconds, from 2 to 5 seconds in the negative direction, and from 5 to 6 seconds to in the positive direction as well. So now we just need to add all of these distances up. So I would say distance total is d1 plus d2 plus d3, and that's 52 meters and 27 and 11 meters. I believe they add up to 90 meters, okay? So this is the very final answer, the total distance traveled from 0 seconds to 6 seconds, or during the first 6 seconds, in other words, that was 90 meters, okay? It was a smart idea that we calculated the distances separately, and then we took the absolute values and we added them up, because otherwise we would get the wrong answers, okay? If you don't take the absolute value, you get the wrong answers. Acceleration, we talked about it, and I think this was a good example. It has like many steps, and maybe the interpretation of the positive negative answers in part A. Well, at 6 seconds, the velocity is positive, which means that it's moving in the positive direction to the right. After 3 seconds, the velocity is negative 12, which means that it's moving in the negative direction to the left. So all of these, of course, make sense. So from right to left, velocity is negative. From left to right, velocity is positive. At t equals 2, velocity is 0. At t equals 5, velocity is 0 because the object was at rest. Thank you, and I have no doubt that you will watch this video multiple times, okay? Multiple times to fully understand what was going on, and you have to redo it by yourselves as well. For me here, quickly explaining things is of course difficult, but for you to understand, you have to watch it many times to digest all these new ideas. Thank you.